go, here we go. Coming back to you. Now we're in the calculator aloud section. And so as soon as it pops up, we'll get rolling here on number 19. Please take note, look at 19, 20, and 21, actually in 22, we're all dealing with a right triangle. Since we're dealing with a right triangle, we have Pythagorean theorem available to us. We also have SOHCAHTOA available to us. So it wants us to find length C to the nearest tenth. Well, this is 8, this is 15. We could just take 8 squared plus 15 squared equals C squared and take the square root of that. Now be careful. Some kids like to try to take the square root of this and say it's 8 plus 15, which is 23, which is not correct. Take out your handy dandy calculator if you need to, and you're going to get, just plug it in just the way you see it. So that would be the square root of 8 squared plus 15 squared, and you get 17. So C equals 17. So that's the answer to 19. Measure of angle A to the nearest degree. Well, if I want A, and this is 8 and 15, I could just use easily tangent. Tangent of A equals 8 over 15. How do you undo tangent? Inverse tangent. So I'm going to take the inverse tangent of both sides. So I get angle A equals, so my calculator, I take the inverse tangent of 8 divided by 15, and I get 28.072. So that's to the nearest degree, so I have 28. Now I should make sure that I'm in degree mode, and I am. So 28 degrees is to the nearest degree. Measure of angle B to the nearest degree. Well, if this is 28 and this is 90, I could as easily just go 90 plus 28 equals, subtract that from 180, and I get 62. Now granted it's negative 62 because I just subtracted 180, but I know it's not negative, I know it's positive 62. So angle B is 62 degrees. Done. Okay, match the following values with the list of the trig ratios. Okay, 8 over 15. Well, 8 over 15 is tangent of A. So this is going to be tangent of A. Is there another thing that 8 over 15 could be? Well, I know tangent of B is 15 over 8. So the cotangent would be that flipped, which would be 8 over 15. So cotangent of B is also the same thing as the tangent of A. Now, cotangent of B is the same thing as 1 over the tangent of B. So this is the same thing as 1 over tangent of B. Let's see if there's anything else it can be. I don't think so. Nope. 8 over 15, that's it. Tangent of A, cotangent of B, 1 over tangent of B, done. 8 over 17, so 8 over 17, remember C is 17, so that's 8 over 17, so I'm looking from A, that's the opposite over the hypotenuse, which is sine, so that's the sine of A. If I was looking from angle B, it's the adjacent over the hypotenuse, that would be the cosine of B. Now, remember, if you want to try to use like secant or cosecant, well, secant means that it's 1 over, and so if I just took the sine of A, which was 8 over 17, and flipped it, that would be 17 over 8. That doesn't give me what I want. Or if I took the, now if I took the let's see, if I took the cosecant of A, nope, that wouldn't work. If I took the secant of A, nope, that wouldn't work, because the secant of A would just be 1 over 15 over 17, which is 17 over 15. That doesn't work either. So it's just sine A and cosine B, and you're done. 15 over 17, so again, that'd be the cosine of A, or the sine of B, and you're done. Okay? Now, 15 over 8. 15 over 8, that'd be the tangent of B, or it would be the cotangent of A, because the tangent of A is 8 over 15, and then the cotangent would be that flipped. So it'd be the cotangent of A. Not the cosine, but the cotangent. That sounds like another full class to get. So the cotangent of A is the same thing as 1 over the tangent of A. Oh, I did not see these down here. I'm sorry, folks. Did not see these down here. Which means back up here, tangent of A is the same thing as 1 over the cotangent of A. That's kind of dumb to say it that way, but just to let you know that is the same thing. And down here, then this would be tangent of B would be the same as 1 over cotangent of B. Because cotangent of B is 1 over the tangent, and flipped, it'd just be tangent over 1. Okay, 17 over 8. Well, that sounds like the sine flipped, which would be the cosecant of A, which is the same thing as 1 over the sine, which they do give us 1 over the sine, so that's also there, 1 over sine A. Now, if I looked at this as the cosine of B but flipped, then that would be the secant of B, which would be 1 over the cosine of B. There's your answers there. 17 over 15. So that's going to be the cosine of A flipped. So that's going to be the secant of A, which is 1 over the cosine of A. Or it would be the sine of B flipped, or what we'd call the cosecant of B, or 1 over the sine B. Okay, done. All right, let's take a look here at 23. So 23 says, if cosine, which is your x value, is negative 0.892 in between pi over 2 and pi, so let's just look where that's at. Here's pi over 2. Here's pi. Of course, the x is going to be negative. What are the values of sine and tangent? Well, first I would tell you to find theta. Since we're in the calculator required here, I tell you to take the inverse cosine of both sides. So I come back to my handy dandy calculator, take the inverse cosine of negative 0.892, but now wait a minute, look what we're at. We're in radians. Okay, so I need to come back to mode, change this to radians. So my angle is 2.6, it's this thing. That's what theta equals. So theta is equaling 2.6725 going on. Now it wants to know what the sine of that angle is. So watch, I now just take sine, I hit second. Sorry, let me do that again. So I take sine and I hit second and the negative button right here, which gives me my answer, and I hit enter. And there it is. So that's going to be 0.452. So the sine of theta is 0.452. So in the tangent, I could take the y value, which is sine, over the x value, which is cosine. So I could just take this divided by that. Or I could just take tangent of this 2.6725 thing. So maybe I do this. Maybe I do the inverse cosine of that again to get the 2.6725 in my calculator. Then I hit tangent. Then I hit second, and I push the negative button, which puts in the answer. And I hit enter, and there's the tangent, negative 0.507. So the tangent of theta, negative 0.507. Done. Okay, if tangent of theta is this, between pi and 3 pi over 2, so remember now, so pi and 3 pi over 2, that's here to here, both sine and cosine are both going to be negative. So I would tell you to take the inverse tangent of that. Take the inverse tangent of that. That's going to tell us what theta equals. So on my calculator, I take second tangent, right? Second tangent, inverse tangent of 3.791. 3.791. Hit enter. That tells me what theta is. Theta is 1.31. But do you know what they gave me? They gave me theta in this quadrant over here. Gave me this theta, but I want it down in this quadrant. Well, it's okay. Just remember, when I take the sine and cosine of that angle, so if I go sine, then hit second negative, which is the answer, which means taking this value right here and plugging it in, hit enter, I get 0.967. So sine of theta is 0.967. But remember, I want it in this quadrant, which both sine and cosine are negative. So I just have to put a negative on it, and we're good. Now to find the cosine of it, I might come back, hit second enter a couple times. to get back, taking the inverse tangent of this to get this number again of 1.3129. Then I'm going to take the cosine, and I'm going to hit second negative, which puts the answer in there. And I get 0.255. So the cosine of theta is 0.255. But remember, it's in this quadrant, and cosine is negative, so it's negative 0.255. All right, done. Last page. Woohoo! Let's do her. Dang it, we're out of right triangle. There's no right triangles here, folks. Cannot use our SOHCAHTOA, or we can't use Pythagoras theorem. Now, we still can use law of sines and law of cosines. Just remember, for the law of sines, so sine A over little a, sine B over little b, sine C over little c. To use this one, you have to have an angle and side opposite. You have to have that, and then one more piece of information. For the law of cosines, which is c squared equals a squared plus b squared minus 2ab cosine of c, you can have three sides. You can have two sides and the angle between. You're good. Okay, it says solve this triangle. Well, I have a side, but I don't have the angle opposite. But look, I have these two angles. So that means I can find this angle here pretty easily by taking 40 plus 59, subtract that from 180, and I get 81. So this angle appears 81 degrees. Now, I am in degree mode now. I should make sure I'm in degree mode now because I'm dealing with degrees. So I go back and change my mode to degree. Okay. Now I just plug and chug. Sine of 81 over 14 equals, let's say we want to find little z here. So sine of 59 over little z. What I want is on the bottom, so I'll tell you, take both sides and flip it. So that gives us 14 over sine 81 equals z over sine 59. Multiply by sine 59. Plug it in your calculator just the way you see it. So I might hit sine 59 and my parentheses times 14 divided by sine 81. Hit enter. I get 12.1499, which is 12.15. So z is 12.15. See if that makes sense. 81 is bigger than 59. 14 is bigger than 12. We're good. So far, so good. So now let's go ahead and find this side over here. You cannot use Pythagorean theorem. Got to use law of sines again. So I would tell you to take sine of 81 over 14 equals the sine of 40 over little x. So now take both sides and flip it, and then multiply by sine 40. So x equals 14 times the sine of 40 over sine of 81. So then I get 14 times sine of 40 in the parentheses divided by sine 81. Hit enter. You get 9.1112, so x equals 9.111. Now let's see if this makes sense. 40 is the smallest angle, 9.11 is the smallest side. We're good to go. All right, come here. Notice that I have an angle, but I do not have the side opposite. I have this side, but I don't have this angle opposite. And I have this side, but I don't have this angle opposite. I cannot use law of sines. I must use law of cosines. So let's go ahead and first start by finding r. We can find r and call it c, or r if you want. So r squared equals these two sides, 7.5 squared plus 9 squared. Doesn't matter which one you put where. Minus 2 times 7.5 times 9 times the cosine of 89. Now to get r by itself, this is nice. You just have to take the square root of that whole thing. So I can just plug in my calculator just the way it looks and just the way it appears, okay? So I would take square root, and then I put 7.5 squared plus 9 squared minus 2 times 7.5 times 9 times the cosine of 89. Hit enter, and you get 11.614. So r is 11.614. Okay, now that I know this side, I can use law of sines to find my other sides. I would tell you to find this angle first. So I tell you to take sine of P over 11.614. That's going to equal the sine of 89 over, sorry, that sounds like a full class ticket. This should be sine of P over side opposite, which is 7.5, equals sine 89 over 11.614. Now P is on top, so I don't need to flip it. We're good. Just multiply by 7.5. I'm going to multiply this by 7.5 over here. Then I'm going to take the inverse sine of both sides. So I have to take the inverse sine of that. So you can plug it in your calculator just like this. You guys like to do a lot of calculator work and you don't need to. You just plug it in just the way you see it. So second sine, this is 7.5 times sine 89 and the parenthesis on the sine 89 divided by 11.614 and the parenthesis for the whole inverse sine. Hit enter and my answer is, whoa, that would be because I didn't do the decimal. Right here, guys, look. There's no decimal here. It's 110,000. Sorry. Second enter. Come back and change this 0 to a decimal. Oops, not that one. That one there. Now hit enter, and I get 40.216. So this angle is 40.216. Once I figure that angle out, I can add these two together and subtract from 180 to get this one right here. So I just take that angle plus 89, subtract it from 180. And I get 50.784. So this is 50.784. Again, you might be saying to yourself, hey, how come you're getting negative here? Because I didn't actually subtract this from 180. I actually took this, subtracted 180, which gives me just the opposite of what I want. So instead of a negative, I know I want it to be positive. So it's 50.784. Okay, look at 27. Sorry I didn't give you guys much room on this review. I can tell now. I have three sides. If I have three sides, I have to use a lot of cosines. So I would tell you to find the biggest angle first, which the biggest side is C, which means we're going to find angle C. So use the cosine of C, which means we're going to take 35 squared equals 30 squared plus 26 squared minus 2 times 30 times 26 times the cosine of C. Now I saw a lot of kids making mistakes like this on the quiz the other day. Please be careful. You can combine these and subtract it over, but you cannot combine this. This is all multiplication right here. The only way I'm going to be able to get rid of this is through division. So you can add these, square these and add them, and then subtract them. I just do this. I just say subtract 30 squared, subtract 26 squared, because I know I'm going to bring these both over to get rid of them. So in my calculator, it's as simple as 35 squared minus 30 squared minus 26 squared equals, and I get negative 351. That's going to equal this. So that's negative 2 times 30 times 36 times the cosine of C. I'm going to divide by negative 2 times 30 times 36 to get rid of that. Notice I put it in parentheses, negative 2 times 30 times 36. So in my calculator here, I just hit divide by parentheses, negative 2 times 30 times 36, and I get 0.1625. That's the cosine of C. Now to find C, I just take the inverse cosine of both sides. So I'm going to take the inverse cosine, and remember, second negative is my answer, and I get 80.648. So angle C equals 80.648. At that point in time, I'd use law of sines, so I take the sine of 80.648 over 35 equals, and I'd find my smallest angle, which is going to be B. So that's going to be the sine of B over 26. By doing so, I'm hoping to eliminate the ambiguous case. So I multiply by 26. take the inverse sine of that whole thing. I plug it in just the way I see it right there. So I just take second sine 26 times sine 80.648 and the parenthesis for this sine divided by 35. This parenthesis is for that inverse sine. Hit enter and you get 47. So that's going to be 47.137. And that's going to be angle B. Now, if you look at its ambiguous angle, the ambiguous angle would be this minus 180 or 180 minus that, right? So its ambiguous angle is 132.86. Well, that doesn't make any sense because B's got to be the smallest side and 132 would be the biggest angle. So I can immediately eliminate the ambiguous case. Woohoo! Ambiguous case out. So the last thing I need to do then is just take this plus my other angle, subtract from 180. So I would take 80.648, add it to 47.137, subtract from 180, and I get negative, well, it's not negative, so angle A is 52.215. Okay, so there's your answers. 28. A triangle, we're almost done, folks. Woo! Triangle has two sides measuring 10 inches and 12. The angle opposite the 10-inch side measures 30. So I have a triangle, has two sides measuring 10, 12. Opposite the 10-inch side measures 50. Sorry, so that's 50. Solve the triangle. So we're going to find this angle here. So we'd say, let's call this A, we'll call this B, we'll call this C. So I'll say the sine of A over 12 is equal to the sine of 50 over 10. Multiply by 12. Take the inverse sine. So I get angle A is equal to, and I plug it in, second sine 12 times sine 50, and that parenthesis divided by 10, and I get 66.817. 66.817. Now, if I subtract that from 180, the ambiguous angle is 113.183. Let's see if that makes any sense. Well, if this was 113.183, is that the biggest side? It is. So, yeah, there's an ambiguous triangle that could happen here. So, there is another triangle possible. We could do this angle as 66.817, which means if I add that to 50, so 66.817 added to 50, subtracted from 180, I get 63.283 would be the other angle. So this angle up here, B, would be 63.283. To find this side, I would just take sine of 63.283 over little b is equal to sine 50 over 10. Take both sides and flip it. Multiply by sine 63.285. So b equals sine 63.283 times that by 10 over sine 50. Plug in your calculator just like that. So sine 63.283 and that parenthesis times 10 divided by sine 50, and you get 11. So b equals 11.660. That's one triangle. The other triangle, of course, it wouldn't look quite like this. What it would look kind of more like would be this. The side is 12. Side is 10. This angle here is 113.183. This angle here was 50. So now if I add those together, 113.183 plus 50, subtracted from 180, this angle up here would be 16.817. And so then to find this side, I would take sine of 16.817 over little b is equal to sine 50 over 10. Take both sides and flip it. multiplied by sine, so b in this case would equal 10 times sine of the 16.817 over sine 50. So in my calculator I get 10 times sine 16.817 divided by sine 50, and I get 3.778. That'd be this side. Okay. Woo! Two triangles, ambiguous case. Gotta love it. Last two problems. Find the area. To find the area, you need two sides and the angle between. We got it. So it's just 1/2. The two sides multiplied together times the sine, 73. Always the sine for area, never the cosine. So then I would just take 1 divided by 2, which is 1/2. Oops. 1 divided by 2 times 8.7 times 12.4 times sine 73. I'm in degrees. I get 51.583 is the area. 51.583, and then my units would be squared, whatever they are. Okay. Carlos wants to find the value of cosine theta given that sine theta is this. He finds that cosine theta is the same value. Is this possible, or did he make a mistake? Well, heck yes, it's possible, because if you remember correctly on the unit circle, there is one location that sine, which is the y value, and cosine, which is the x value, are exactly the same. It's right here, positive. Square root of 2 over 2, square root of 2 over 2, which is 45 degrees, or pi over 4. Folks, drop the mic. We're done, baby. Hey, hope you guys have a great day and a great Thanksgiving. I also hope that, I just want to say, first of all, thank you. Thanks for being great classes. I know I got a little upset maybe at my B5, B7 class the other day, and I'm sorry. I do want to tell you guys I do appreciate you. And I thank you for doing all that you do. Thanks for being great students. And I wish you the best of luck in review here. All right. We will see you later, taters. Have a great day.